So, gents, I thought I would just quickly go through my approach to this question, fairly typical HSC question, just to go through the steps about how I would do it. So just a reminder that this is the plan stage. I won't be writing out the full solutions, just planning out what I'm going to do here. And to do that, I'm going to look at what the question has given me. I'm going to think about the common rules, and then I'm going to have a look at the marks. So, in this particular case, we're going to have a quick read through the question together and then have a look at what they've given us. So the points PQT line of circle. The line MN is tangent to the circle, so that's going to be important later. At T with M chosen so that QM is perpendicular to MN. The point K on PQ is chosen so that TQ is perpendicular to PQ, as shown in the diagram. So before we do anything else, let's talk about that tangent. There's only a few rules that concern tangents. One of them is tangents drawn from external points, the same external point, are equal, but we only have one tangent, so we're not going to use that. We have the tangents are perpendicular to radii at the point of contact, but we don't have the center of this circle, so we can't possibly have a radii. The other one is a secant and a tangent, the relationship between the intercepts of the secant and the square of the tangent. In this case, the only secant that is drawn from the same point as the tangent is QM, and you'll notice that this point here is not labelled. So there's a very good chance we're not using that one. The only one that leaves us with is the angle between a tangent and a chord. Chord and tangent angle. Now the reason I'm writing that down is, if they've given you a tangent, then you will be using it. And this is really the only reason that is left for me to use. So I'm pretty sure I'm going to use that at some point in the question. So let's have a look at the first part. Show that QKTM is a cyclic quadrilateral. So I'm just going to draw that quadrilateral in. Here we go. Now we know there's only two ways really to prove cyclic quadrilaterals. The first one is proving that opposite angles are supplementary, and the other one is that the two of those points subtend the same angle at the other two, and then it's just the converse of equal chords subtend equal angles in the same segment. So in this particular case, we're going to use opposite angles as supplementary. That's 90 degrees, that's 90 degrees, almost basically given there. Therefore, QKTM is cyclic as opposite angles are supplementary. The next part, show that angle KMT, I'll just draw these in, KMT is equal to KQT. We're going to use two things here. Okay, two big hints that pop out for me. First one is this is a part 2. If you're doing part 2, there's a good chance you're going to need part 1. So I have noticed that K, T, M, and Q are all on the circle that I just found. So I'll have to think of them like they're lying on a circle. The other one is in the names. Here we have KMT and KQT. Both of those angles start with the same letters. So all of those hints point towards angles subtended by the same chord, and that is in fact exactly what this is. KTMQ is a circle, KT is a chord in that circle, and it subtends the angle alpha at Q, and therefore will subtend the angle alpha at M. So the only reason we need there is that the equal chords, or the same chord, subtends equal angles in the same segment. The next one is worth 2 marks. So already I'm thinking, great, I'm going to need 2 things to do that. And it asks me to prove that 2 lines are parallel. Just removing some of this information here that I don't think we'll need anymore. It asks us, in fact, to prove that these 2 lines are parallel. Now, proving things are parallel is a 2-unit question, and almost always involves showing that corresponding or alternate angles are equal, or co-interior angles are supplementary. However, there's a bigger hint. I'm yet to use this reason. So having a look at what I have, which is those 2 angles there marked as alpha, and trying to look at, well, how can I use this rule, the chord and tangent angle, chord between a tangent and the angle between a chord and a tangent rather, and what I currently have, and one of them sticks out. This angle here is subtended by the chord PT, and the chord PT meets the tangent. So it means that this angle here must be alpha. Once I've done that, the second part of this question is very simple. this angle and this angle are now the same. They are, of course, corresponding angles. Therefore, MK is parallel to TP because corresponding angles are equal. So, in summary, I looked at what the question gave me and worked out very quickly I'm going to be having to use one particular rule involving tangents. The next big hint out of this was part 2 needed part 1. Very common in circle geometry questions. And the last one was I needed 2 things for a 2-mark question, and I looked at, well, what are the 2 line geometrical reasons that I'm going to be using? And that's the big hint for that one.